And for everybody, if I use the word that once Dr. Harsha Gupta used, it is selfless service of the people. They are not doing this with a motive whether I can write a paper, whether I will get an award, or whether I will get publicity. For them, this is their service to the nation. And that's how we made this Mangalyaan mission possible. Even though we had only a calendar year of 1 year, the spacecraft had 24 hours a day and people were coming throughout and working on it. That's why we did everything. So what we focus here is team excellence. It is the excellence of the team rather than individual excellences. It is a question of synergy of the people. It is the secret of everyone coming and rising to the occasion. And during these launch campaigns, one can tell the stories. You will have so many difficult situations. Just to tell you two things. Before Chandrayaan launch on the previous day, we had a leak of fuel and difficulty to even load fuel. All this happened in torrential rain. People did that and still met the launch time 6:22 a.m. in the morning. 2013 August, we went to the launch pad with a GSLV and our Indian cryogenic engine and stage. We had a failure of that cryogenic stage, similar system, couple of years before that in 2010. We had an extensive amount of work on looking at GSLV per se and the cryogenic stage per se. We were ready for the launch. 1.5 hours before the lift-off, we found leaking of the fuel in the second stage of GSLV. Of course, action was taken to reduce the pressure. The launch was cancelled, aborted. But here you see there was a vehicle sitting with almost 300 tons of propellant loaded into that, with all ignition systems given the arming position. That means if it gets an electrical signal, it is ready to ignite. And 1 ton of fuel had already fallen and it was on a metal piece, that is hypergolic system. And that hydrazine, chemists will know what is the danger of hydrazine. 1 ppm, parts per million, is what is allowed as a safe number. And we were there at about 5,000 ppm with all this leak taking place. Something new, something which we had not anticipated of that magnitude. But the beauty of the system is 450 people worked day and night for the next 2 weeks. And safely, this vehicle was brought back to the assembly building. And that is how we respond to the situations. When the spacecraft is in the orbit, we have similar things happening. We had a launch of INSAT 3D in August 2013. After the launch, we had the solar panels deployed. Then for 2 hours, we had a problem. There was no communication with the spacecraft possible. Look at a situation, the child is born, the child is not crying. Here, all our people put their mind together. They were able to find a way of reducing the kind of rotation that was taking place. Normally, 3 degrees per second is what is allowed. What is the capability of the gyro system to capture it? Here it was going at 60 degrees per second. But those who knew the in and out of the system were able to find out how manually they would be able to get into and what is that novel way of communicating with it. And they got it within 2 hours back to the condition in which it was just launched. These are the occasions when people come to face those, evolve as a team, and nobody has to give an instruction at that time. That is another strength of ISRO. And this is what we gained from our past. SLV-3 first flight was a failure. The chief of ISRO faced the music. Second one was a success. The project director was asked to go and brief the media. This system continues. No witch hunting, no pointing of fingers when there is a failure. We learn from the failure. We sit together not to point the fingers at somebody, but point fingers at the issue that created the problem and find a solution to the problem. That is why we have been moving forward, and this is a lesson for anyone. Team excellence, self-service, and how you face a failure and how the leader has to conduct during a failure and bring the team up. These are some of the things which I would say and then leave it later for discussion if we have time. Let us come to the global space today. When the modern space started in late 1950s, precisely with the launch of a spacecraft by Russia followed by US, there were two countries. Bipolar world was there. A few more joined. India was one of the first to be in that line. But today, there are 65 nations. These states means nations, who are having space activity, making rockets, making spacecrafts, or being an owner and operator of these systems, or using them in a major way. If you look at the UN Committee on Peaceful Use of Outer Space, there are 83 members. That is one part of it. This is a multipolar world today that we have. And if you look at the last few years, maybe a decade, this number is increasing exponentially. That is one part of it. If you look at the global economy, the size, that is another indicator, it's about 360 billion US dollars. It's a quite large number. This has 25% contribution from the government budgets. 75% is coming from commercial operation of the space infrastructure, products and services. It's a very major change that has taken place over the last so many years. Those who have the ability to launch are a dozen or so. There are about 30, 40 nations who can build spacecraft and operate them. But there are something like 5,000 firms who are into downstream services using the transponders or using the satellite data to provide the service to the end users. If you look at this 360 million US dollar, the launch and the satellite constitute about 10%. The equipments required for using these systems on the ground, that may be about 30%. The balance is coming, major chunk is coming from the downstream users. Stakeholders are many in this system today. And if you look at the satellites, as of now there are 1,450 operating. Much of it is for communication and navigation. And India too, we have a constellation of nearly 45 satellites today. Communication, remote sensing, meteorology, navigation. Bipolar world, competition, and space was a medium for showing the power for one-upmanship, one point of view. But today, there is international cooperation, bilateral, multilateral happening. I talked about the Chandrayaan mission. Subsequently, we had two French satellites jointly built by India and France, Megatropis and Saral, and now we are making a satellite along with NASA. It's called NISAR for remote sensing applications. But what is very striking is last 3-4 years, 15 space agencies have been sitting together and preparing a global exploration roadmap. Starting with the International Space Station, going to Moon, going to have gateways, human-tended facilities, and finally getting into Mars. So this is something which is unique. We are looking at, humanity is looking at together the. And what is happening today, and what is this new space age? There are essentially 5 facets of space activity. One is space exploration, exploitation, then the engineering aspect, space as an enterprise, and finally the engagement. If you put, where is the world going? Solar system and the universe. You all know about the Hubble telescope and its next generation system, the James Webb telescope, and there is a Herschel of Europe. They are all looking at our universe. If you look at the sun, the latest development is a Parker solar probe, which is going to go near sun and try to understand that beautiful phenomenon of corona. Where is India in this? India's AstroSat again looks at the universe, and there are wonderful results which have come out of it. It's a multi-wavelength space observatory for astronomy. It's a new tool for the global astronomical community. If you look at the Aditya mission which we are planning, again, it is going to be something quite different from what we have done. We go to a place 1.5 million kilometers, it's called Lagrangian point, for observation of the sun. Space environment, harsh, and one major contributor is the sun itself, the solar wind. And this is another area where a lot of research is going on, a lot of observations are going on. Cosmic hazard. We talk about asteroids on one side as a major source of resources. On the other side, a potential threat even to Earth. If an asteroid can come into the vicinity of Earth, what is the impact of it? How do we avoid? This is another area of activity. People talk about deflecting asteroids. And when we talk about missions, human missions to Moon or Mars, how the cosmic objects are going to affect it. This is one aspect of it. The word exploitation is becoming a reality now. Why we are going to Moon? Why we are going to Mars? What is that we are going to get for energy? Solar power satellites. How to get resources from Moon, helium-3, which is a major energy source. When we talk about Mars, again, Mars habitats. So this is something which is happening. And if we are having a colony in Mars, which is the dream of people, maybe 50, 100 years from now, there could be colonies in Mars. Do we have to carry all this material from Earth and build the colonies there, or can we use in situ resources and build? And people are also dreaming about using the resources from asteroids for such kind of an activity in Mars. So this is something which is partly fiction, partly dream, and partly a target aspiration for several in the global space community today. When we talk about human space flight, is the first step that we are doing in terms of understanding what is involved in carrying a human being, keeping them safely in space, and bringing them back safely too. And if you are talking about the resources to be brought from moon, that means we have to have powerful rockets, go there, get into the surface of moon, do the excavation, carry that material back to Earth. And if you have to bring a ton or 2 tons back to Earth, you require a rocket that will have almost 60 times of that capability. That is, if you can put 60 tons into low Earth orbit, the kind of thing we talk about Falcon Heavy, then yes, we can bring back after all this operation a couple of tons back from moon out. This is one thing that is happening. But when you talk about the spacecraft, one important thing is to have high power communication satellites, large amount of power to be dealt with, more number of transponders, higher frequencies, long life of 15 years plus, so that we can maximize the return on investment. When we talk about science, when we talk about remote sensing, we look for versatility, induction of new technology, a group of small satellites, formation flying. This is one thing which happens. When you talk about human space flight and the difficulties of sending and bringing the human being, the other option is to have robotics. But people will say robot does not have the cognitive capability that human being has. And there is a drive now worldwide to bring into at least some part of that capability into the robot. Brain-inspired robots is a key word these days. Debris. This is a subject of interest because the orbits in which the satellites operate have a lot of old satellites parts going around, almost 17,000. How do we find out where are they? How do we characterize its motion? How do we ensure that they don't hit any of the satellites which are operating? And how do we scavenge? So this is part of the debris management. And the space gateway around moon or Mars, this is new thing in engineering part of it. When you talk about enterprise, we talk about today's satellite constellation as a big business actually. 1,450 spacecrafts for various applications. Build, deploy, and create these as space assets and ensure security of those space assets. Electronically or physically, one should not destroy or one should combat those from any such events from outside. And finally, how these spacecrafts could be used for human welfare. That's what we have been doing. So whenever you see a cyclone threat today, it is a matter of practice. Everyone knows what is the standard operating procedure. The spacecraft will provide the information about the movement of the system. 48 hours in advance onwards it starts. The IMD colleagues will have the modeling done properly and they advise where it is going to strike, what is to be done by the local people, and all these are for the human development, sustainable development, and these days we have the sustainable development goals, 17 of them, in which at least 12 have to be done with the data from spacecrafts. And finally, it's also used for surveillance, and in US today they talk about a space command, that's for supremacy. So this is where I just want to conclude my presentation and In the light of the human space flight, there are new areas of research which India need to take up. One is astrobiology, bioastronautics, and this is a common point that the space community could see with the CCMB family. And I am sure that these two groups of brains together can take the country in a major way forward. I have been told that maybe a couple of questions could be there. We are already at 5:55.